about this. So basically, banking of road means outer edge of the road. You can see here, outer edge of the road is raised to higher level than inner edge, and this arrangement of the road is called as banking of road. Now you can see in a picture here. So you can see this is inner edge of the road and this is outer edge of the road, and this is a vehicle. This is the horizontal road. But if we raise this outer edge with some level, then that arrangement of the road is called as banking of road. Now this arrangement of the road is called as banking of road. Now here, so this is surface of road now, and this is horizontal, and this angle is theta, and this angle is called as angle of banking. So this is very important term, angle of banking. Angle of banking means angle between surface of road and horizontal, or in another word you can say that the angle between inclined surface of the road and the horizontal is called as angle of banking. Now in this in the next article we have to obtain expression for angle of banking also. Now you can see here bank road, it's a racing track. So this is the outer edge. Outer edge is at higher level than the inner edge, and that arrangement of the road is the banking of road. So this type of arrangement we can make it to increase the speed limit on this curve path. Generally, so this is a racing track. So outer edge is maintained at more higher level as compared to the inner edge. But you can see in a normal road also, on highways also, you can see the outer edge is raised at higher level than the inner edge. So here, when the vehicle is on the bank curve road, then banking of road means what? The arrangement of road in which surface of the road are tilted with the horizontal with some angle. This is called as banking of road. You can see here, this is a vehicle. Now here we have to discuss what are the forces acting on this vehicle when it is moving on the bank curve road. So before that forces, we can discuss here why this banking of road is necessary. In application number 1, we learn maximum velocity of vehicle on horizontal curve road, and in that we get V is equal to under root mu rg. This speed, safety speed limit depends on coefficient of static friction, radius of the curve path, and acceleration due to gravity. In that, for a particular road, G and R is constant. Means both are constant. R and G, both are constant. But here, mu is a coefficient of static friction. It depends on the season. It depends on the condition of road. Means if road is wet, if oil is sprayed on the road, then mu changes. So here, this friction is not reliable way to provide this centripetal force required on the curve path. And because of that, banking of road is necessary. So you know that when vehicle is moving along curve road, performing circular motion, and for which centripetal force is necessary. And that centripetal force is provided by the force of friction. And if this centripetal force is lesser, or in absence of such force, UCM is not possible, that you remember. So means centripetal force is necessary. And if it is zero, then circular motion is not possible. And the vehicle is in danger of being thrown off the road. Now here, in case of horizontal curve road, you know that just we discussed here, friction is providing the centripetal force. The force of friction is not reliable, that you remember, because it decreases when the rain is there, when oil is sprayed on the road, as well as if the road is a smoother, means maybe it depends on the condition of road, you can say that. So when the friction decreases, you have to decrease the speed limit on this curve path. And in other ways, if you want to increase the safety speed limit on this curve path, then you have to make it more and more rough. But it causes wear and tear to the tire of the vehicle. To avoid all these, banking of road is necessary. Now here, so banking of road, basically let the car move on horizontal curve road. I consider this is a horizontal curve road and car is moving on that. Then we have to discuss forces acting on car. Basically the first force is weight mg. So I can write small m, capital M, it's okay. So weight is mg. Then second force is normal reaction. So it is a reaction force exerted by the surface. Basically, normal reaction is perpendicular to the surface of road. So I shown first horizontal road. This is a horizontal road. But when the road is banked, you can see here, this normal reaction is perpendicular to the surface of road. So the direction of this normal reaction you can see in a diagram. So this is a normal reaction. And this is a weight mg. Now here, this normal reaction we can resolve into two components. So the first component is n cos theta, which is the vertical component, and second component you can see in a diagram n sin theta. So this is the horizontal component. Basically, you remember one thing here, always the adjacent component is in cos, and the same component, this sine component, we can show opposite to the theta also. So this is n sin theta. So here, this horizontal component is in sine and vertical is in cos. Now after that, we have to discuss the third force acting on the vehicle, and it is a friction. So you can see here force of friction between tire and road. So this force of friction also we can resolve into two components, f sin theta and f cos theta. If this is a force, then obviously this angle is theta. Then adjacent component. So this is the adjacent component and it is in cos. So f cos theta. And the another component here, the opposite component, or here this component is in sine. So you can see f sin theta here. So this component diagram you try to understand, because we have to use this diagram while deriving a derivation. Now let's see a derivation here. So here we have to write maximum speed of vehicle on bank curve road without considering friction. See here, this is very important word, without considering friction. Now in this article, this is a point number 1. So here we are not considering friction. So friction is 0. So here we are considering only two forces which are acting on vehicle. First one is the weight and second one is normal reaction. Friction is 0. So we are not considering that frictional force. So consider a vehicle of mass m moving on bank curve road of radius r as shown below. So let I show you a diagram. So this is a vehicle which is moving on bank curve road. Now after that, forces acting on vehicle, the first force weight and second force normal reaction. Now here, so this type of picture diagram is not useful in the physics. We require component diagram. So let I show you component diagram also. So before that, you remember here, we can resolve this normal reaction into two components. So basically, normal reaction is resolved into two components. First one is n cos theta and second one is n sin theta. Let I show you both in a diagram. So see the diagram here. So this is the center of gravity of this vehicle. Through that center of gravity, I shown weight in a downward direction, and this is normal reaction. These are the two forces. Now after that, n is resolved into two components. So this is n cos theta and this is n sin theta, because this angle is equivalent to the angle of banking. So basically, here we get the component diagram. So we can write it more a proper component diagram also like this. So when you are drawing diagram in an examination, the vehicle is not important. The component is very important. So this is a vehicle. Then this is center of gravity of the vehicle. And through that center of gravity, I shown weight mg in downward direction. This is normal reaction, and it is resolved into n cos theta, n sin theta. So this is the angle of banking, and by geometry, this is also theta. Now here, by using this diagram, we have to write two equations, and these two equations we have to process to get a maximum speed formula. Now, so you can see a diagram very carefully and you can write here n cos theta balances with mg. You can see this n cos theta. It balances mg because vehicle is in equilibrium position. So here n cos theta and mg, they are balance each other. So we can write n cos theta is equal to mg, and this is the equation number 1. Similarly, we can write equation 2. Now here equation 2 we can write in term of centripetal force. Now you know that for any motion of vehicle on the curve road, centripetal force is essential, and centripetal force is along the radius and toward the center. अगर आप ये component देखेंगे n sin theta, this is acting toward the center of the circular path of the vehicle. So this n sin theta is equal to the centripetal force. So I can write it here, n sin theta provides centripetal force. So we can write n sin theta is equal to mv square by r. तो यहाँ पे इक्वेशन नंबर 2 मिल गया, इक्वेशन 1, इक्वेशन 2, दोनों इक्वेशन है यहाँ पे. तो वी हैव टू प्रोसेस दिस टू इक्वेशंस. क्या करेंगे हम, दोनों का डिवीजन लेंगे, 2 डिवाइडेड बाय 1. तो हमें क्या मिलता है देखते हैं. देखिए 2 डिवाइडेड बाय 1 करने के बाद हमें 2 का एक साइड लिखा है हमने n sin थीटा एंड दूसरा साइड है mv स्क्वायर बाय r. 1 का इक्वेशन 1 का एक साइड है n cos थीटा एंड दूसरा साइड है mg. तो डिवीजन करने के बाद यहाँ पे n आप कैंसिल कर सकते हैं, ये m यहाँ पे वाला m कैंसिल हो जाएगा. तो आपको इक्वेशन में क्या मिल जाएगा, साइन बाय कॉस tan, एंड यहाँ पे ये v स्क्वायर डिवाइडेड बाय rg मिल जाता है. tan थीटा का फॉर्मूला मिल गया v स्क्वायर बाय rg. तो उससे आप v लिख सकते हैं. तो v क्या आ जाएगा, देखिए v स्क्वायर इज इक्वल टू rg tan थीटा, तो उससे v आ जाएगा अंडर रूट rg tan थीटा. अभी ये क्या है, सो दिस इज द मोस्ट सेफ स्पीड ऑन बैंक कर्व रोड. So this is a safety speed on bank curve road. So this is also called as optimum speed. Optimum speed on bank curve road. Now here we can write a formula for banking angle also. So by using this formula we can write tan theta is v square by rg. Now by using this we can write theta is equal to tan inverse of v square by rg, and this is expression for banking angle. Listen, in examination problem may be asked, obtain